Hello, this is novaTopFlex. In this video, I will be showcasing a demonstration of how to find and the attempt to find rather the expected value of rolling to the point. How many rolls will I need? Well, how many really it's coin tosses will I need because this is binary, this is ones and zeros. Usually I think of, and you might think of this the same way, 1 is heads and 0 is tails. You could flip this, you could say A, B, you could say X, Y, you could say literally anything for the 1 and the 0. This is binary, meaning that there are only two possibilities. Using a random number, or pseudo-random rather, because truly random doesn't exist on computers, number generator. So really just using the numpy.random.rand is not really random, it's pseudo-random. And I'll talk about that more later. I'll also, of course, talk about standard deviation more in a future video, because the data may appear. Now, when we talk about standard deviation, this could also theoretically be modeled with, if you can find the standard deviation of this data set, then numpy.random.rand n with an n is going to create, kind of I think it's a Gaussian, I'm not sure if it's called a Gaussian set, but it is supposed to follow the bell curve. It is supposed to be Gaussian random, and it's obviously, as it is Gaussian, supposed to follow the standard deviation. So the mean is 0 and the standard deviation is 1 in the data set provided by RAND-C. Your standard deviation for other things is almost certainly going to be different and most likely not exactly 1, nor is a mean likely to be 0. So you can expect also, by the way, from the previous video, if you watched the first part, please do so. But if you're just starting out on this video, this is actually part 2, I'm going to tell you this. The expected value is supposed to be around 2 to the 10 minus 2. 1024 minus 2. That is the equivalent of 1022. Now let me keep going. 2 to the 2 minus 2 is the expected value with 1. So really, as 4 minus 2, or 2, again, the sum from 0 to x, from I equals 0 to x of 2 to the really, not really that, more like the sum from I equals 0 to x minus 1, or I could also say, instead of doing that and doing the n to the I plus 1, I could say also the sum from I equals 1 to x of n to the I, or really, no, not n, 2, sorry about that. It's already 2 to whatever power. So really, whatever the summation, it's supposed to be 2 to the 1, plus 2 to the 2, plus 2 to the 3, plus 2 to the 4, and so on, up to 2 to the 9. So that's going to be so that's 2, 6, 14, 30, 62, and that's only for 5, 126, 254, 510, 1022. So the expected value is supposed to be around 1022, meaning it's supposed to take about 1022, on average, 1022 coin tosses in order to get 9 zeros or 9 tails, or if you use 0 for heads, 9 heads in a row. So 9 in either direction in a row, you can expect it to be around 1022, and that's only if you're looking at one-sided. I don't know if it becomes 511, or it might not become 511. Please tell me in the comments if you know the math for how I can get to an expected value for how many times it takes to get at least 9 heads in a row, or at least 9 tails in a row. This is only with 9 tails in a row. Now, you will continue to see that this program is pretty slow. This is because it is trying to repeat the process. I believe it's trying to repeat the process 1,000 times, or is it 1,000,000 times? I don't think I remember if it's 1,000 or 1,000,000. If it's 1,000,000, then it's going to be significantly slower than if it is 1,000. However, it gets exponentially slower as I try to force higher numbers. And yes, I think that it also has an overflow, or I'm not sure if it's an overflow. I think that it says segmentation fault or segmentation error core dumped. is what I got when I tried to do it with 15 or 16 or really maybe even only with 14 or even 13 in a row. But 9 in a row is perfect. It is a slow and steady pace. It is not too slow, not too much pressure on this computer system. If you have a more powerful computer, maybe you might have better outcomes with 13, 14, 15, 16, or so on. I do not know if you're running into quantum territory at any point, but yes. And more content, of course, is coming soon. And the expected values will also be available in a later video. And if you like this type of content already, then please consider liking, sharing, commenting, subscribing, and trying to hack the YouTube algorithm. And there is more. This is supposed to be thought of as a series for expected value, probability, statistics, etc. These random number generators are very essential in Python and the Python libraries, and this video uses the modules sys for sys2argv for passing arguments to the command line, numpy, and really, I think it's it. But thanks for watching. Signing off.